Hello friends, this is Jim here with Science Talk, and in this video I'm going to share with you some statements made by scientists. So it's not necessarily bringing you studies, published research, newly published research, but what does it deal with? Feedback loops. It's already begun. Feedback loops will make climate change even worse, says scientists. So when the United Nations, the IPCC, or Intergovernmental Panel on Climate Change, released their rather disturbing report this past October, basically saying, humans, you better get your act together. The new estimate about how much additional CO2 was being added to the atmosphere. And we need, basically, the IPCC was saying we need to address that. There's feedback loops like that one, okay, right? Because you release greenhouse gases, which speed up the warming, which then causes, say, more thawing, more melting, thawing, what have you. Releasing more greenhouse gases, increasing the temperature, etc., etc. You get that feedback loop. I have discussed feedback loops in a number of my prior videos. So Dr. Thomas Crowther, who is a professor in the Department of Environmental System Science of ETH Zurich, says it has already begun. The feedback is in process. Crowther estimates that CO2 and methane emissions from thawing soil are accelerating climate change about 12 to 15% at the moment, and said past IPCC reports that left out the feedback were way more optimistic than they should have been. Well, let me tell you that Dr. Crowther is being extremely kind and diplomatic. I probably would not be as kind and diplomatic. I have problems with the IPCC because having been involved in with a team of researchers from Alaska, we prepared our contributions to these reports. It has always ticked me off to no end how the methane question was always shoved under the rug. Come on, a major contributor, and they have always downplayed, the increases, what's really going on. And really, in the long run, they're not doing a service here, doing a disservice, if anything. But the IPCC is, to be blunt, a political body, and I don't think I need to say any more on that. So, yeah, they have always painted it nowhere as bad as it really is. So then, when other reports come out independently saying things are pretty frickin' bad, then we get called, you're just being hysterical, or there's something wrong with your analysis, you're overestimating, what have you. When it's really the IPCC has been underestimating all this time. Almost every scientist studying the effects of climate change is worried about the extent to which feedback loops will hasten global warming. The other mistake a lot of people make is they're assuming a linear increase in temperatures and CO2 levels, methane levels, whatever it may be, whatever the parameter under consideration. Let me go back to what they said, 12 to 15% at the moment. That leads to an exponential increase. 12 to 15%. E to the 0.12, e to the 0.15, right? That kind of stuff. Whatever the base may be, I'm using that as an example. But the thing is, that leads to an exponential. So you could create exponential increases in the climate and how it's being changed. One of the most serious concerns is the albedo effect. The amount of the sun's radiation the planet reflects back into space, mostly from the polar ice sheets. The warming that has already occurred has begun melting the ice caps, leaving the relatively dark ocean on land exposed to absorb the solar radiation, which further warms things, leading to more ice melt. See where that's going. And I discussed with you about, the methane question. The air warms, more of the permafrost thaws, more microbial action, releasing more methane, more warming, more thawing, more methane, etc. Well, more dark areas, land, water, more sun energy absorbed, more ice melt, more land area, open water created, more sunlight absorbed. All these positive feedback loops. Positive feedback loops lead to runaway systems. Negative feedback loops are corrective. So Dr. Jennifer Francis, who's a senior scientist at Woods Hole Research Center, said the impact that it has on making the Earth darker by removing all the snow and ice is estimated by some to be 20 to 40% of the warming that we have experienced. In other words, global warming is that much worse. There's a lot of ways these things are totaled altogether. It's the cumulative. Now, feedback loops are not a root cause of the climate change problem, but they make it worse. Now, when scientists began examining climate issues back in the 70s, there really was no idea how the feedback loops would work, how they would operate, if there was indeed a problem with them. Scientists at the time also thought about negative feedback loops, something that would be corrective in nature, slow down the warming, for example, increasing cloud cover. So far, it's all gone the other direction, the wrong direction, if you will. We're now finding that increasing the warmth of the atmosphere is dissipating clouds. Dr. Francis continues, I'm not optimistic. It's not just because of those feedback, it's because we've already put so much carbon dioxide into the atmosphere, and carbon dioxide lasts a long time. It goes back to the thermal inertia concept I have repeatedly discussed in my videos. Not only CO2, but methane, water vapor, and now possibly nitrous oxide. A molecule of CO2 on average lasts about 100 years in the atmosphere. So we haven't yet felt the impacts of the CO2 that we've already put in the atmosphere. This is Dr. Francis' statement, continuing. Even not thinking about feedback, we've already got a lot more climate change built into the system just because it takes a while for the climate system to adjust itself to this new level of greenhouse gases in the atmosphere. All the feedback that happens is just making the response, that response, even bigger than would be otherwise. Again, it comes back down to the thermal inertia, and I've also stated in the past that humans have perturbed the system, and the system, in trying to find its new equilibrium point, is going through these machinations. And as long as we keep perturbing the system, we're going to keep, the system is not going to find its new equilibrium state. Make it for some interesting events, shall we say. So what is Dr. Francis, what's her area of research? She's researching how rising Arctic temperatures have been weakening the jet stream, causing shifts in weather and ocean current patterns that, and yet another feedback loop, warm the Earth and further destabilize the jet stream. Warm the planet, affect the jet streams. Further warm the planet, further affects the jet streams, breaking them down. What we're seeing is that the Arctic is warming much faster than the planet is farther south. And we know that the Arctic is the fastest warming region on the planet, making that north-south temperature difference much smaller. Okay. So let's say, average summer temperature, let's say the average summer temperature is 40 degrees over Barrow. Full of stuff here, and let's say down in the temperate zone is 70 degrees. Okay, 30 degrees different. I'm using Fahrenheit numbers. Let's say the Arctic warms up to 50, 55, 60. The temperature difference is smaller, which means the gradient is smaller, is less. And if you have and temperature gradients, okay, warmer temperature leads to, the air is expanding, so it's reduced pressure, reduced density. So now you create pressure differentials. Pressure differentials is what drives winds. Wind is really the atmosphere in motion. So if this temperature difference is smaller and smaller, then there's going to be less of this gradient that's going to be driving wind pattern, be it close to the ground or up in the high atmosphere, such as where the jet streams are found. Now, this can slow down the jet stream, but could also cause the jet stream to take more of a big, instead of being like going tightly around high latitudes, it might really dip down far south. And so you get these big north-south swings that goes on. And that's important because the waves in the jet stream are actually what create the high and low pressure systems. That, when you open up a newspaper, I know, how quaint, open up a newspaper or flip on the Weather Channel and you see, an H with isobars around it and an L with isobars around it. Okay, they're there because of the jet stream. Jet stream tracking the high and low pressure systems around. So you get these big waves in the jet stream, they tend to move more slowly. So the highs and lows you see in a weather map will also move slowly, will persist. So if you got a low pressure system that's dumping a shitload of rain, like Hurricane Andrew, it's going to move slowly. So it's just going to park its ass and just keep dumping water on you. And what's going to happen? So you're going to see more persistent weather patterns and weather systems. And of course, that has devastating consequences. Harold Wanless, who's director of the University of Miami's Geological Sciences Department and a leading expert on sea level rise, has studied the rate at which the oceans have risen and retreated over millennia. His concerns that a variety of feedback loops will contribute to a dramatic increase in sea level in the coming decades. He states, "My work on ancient climate shows we have these rapid pulses of rise that are rather dramatic, up to 10 meters of sea level rise, certainly within a century. And that's a really rapid disintegration of ice. We're just seeing the beginning of ice melt and the beginning of the warming of the waters reaching up to the Arctic, what is most certainly going to be the beginning of one of these rapid pulses." It was just 84 degrees Fahrenheit reported by the Arctic Ocean just the other day. Holy shit, I don't remember that. Things are happening. To Wanless, the evidence is clear. We've already reached a tipping point when it comes to the cascading impacts of climate change on sea level rise. Add to that thermal expansion. Dr. Wanless continues, once you start adding up these different feedbacks, because that's the only thing we have to go on in the modern era. Now, oftentimes scientists will look at what's happened in the past, look at the conditions that created the situation in the past. Once we understand that, we can then say, okay, this is what can we expect for these conditions in the future. The same, you can make predictions about the future by looking at the past. That's basically what he is doing. There are all these things that are speeding up ice melt, some of which are just becoming aware of, like the collapse of the high ice sheets. We're just trying to figure out how fast and how dramatic that will be. A lot of them work together. The warm water getting in under the outlet fjords of Greenland and Antarctica that end up detaching the ice from the substrate. And once that happens, you can have the sort of automatic fracturing of the detached ice like stacks of books starting to spill out from a table. I have in previous videos discussed all this bit of ice that's grounded on the bedrock, ice that extends out past the bedrock, so it's now like cantilevered and have water underneath it. Now you add warm water underneath that, you're going to start eroding that ice from underneath, where that could then split off from the grounding line. And then you have an iceberg floating away. Currents carry into warmer water, it melts, contributes to sea level rise. So it's kind of what he's getting at here. But now we're seeing that the melting is actually starting to speed up. Again, a lot of these changes are not linear. They're going to start becoming exponential. And eventually it will turn into a logistical model, which is a combination of exponential and logarithmic, be that as it may. But the changes, the feedback loop will actually accelerate things so that it goes from being what appears to be a linear change to an exponential change. And that does not bode well. It's sobering to realize the extent to which the planet's ecosystem is interconnected. For years, relatively little was known about the vital role the Arctic played in keeping the world stable. You know, the Arctic, Antarctic are called the world's refrigerators. As the permafrost has begun to thaw, however, the global ramifications have become unavoidable. Permafrost acts like a giant freezer. The reason we have freezers in our kitchen is you put organic carbon in the form of food in your freezer and it doesn't decompose. This is a statement from Charles Coven, who's research scientist at Lawrence Berkeley National Laboratory. He continues, the same thing happens in these Arctic ecosystems. Plants grow and then die and form organic layers, kind of like compost, on the surface of the soil, and then over time, that carbon gets mixed down deeper into the soil, where it gets locked into these deeper layers, where it gets frozen and can stay for thousands of years. Coven is the author of a 2015 study that found that every 1 degree Celsius of warming releases from the permafrost the equivalent of 1.5 to 2 years of human-generated global CO2 emissions. When you have warming, it causes the layer of soil that thaws every summer to thaw a bit deeper. Right? There's with the permafrost, there's a seasonal thaw layer, which is where the sun energy can reach. That now starts reaching deeper. So it's sort of like you take your frozen food in the fridge and move it into the refrigerator portion. You take it from the freezer, move it into the refrigerator portion where it's not as cold, and eventually what? It thaws out. So that frozen slab of meat becomes not frozen slab of meat. Basically, that's the idea here. That's that kind of analogy. So it won't last as long. Then it decomposes. And then you have what? And this is the organic layer, right? Decomposes and you release all these gases. I used to, many years ago, I worked for a kind of like a summertime gig, worked for a tour company. We'd take people up to the Arctic Circle. And there's this one spot near Finger Rock. Finger Rock is this huge volcanic outcropping thing. And they called it Finger Rock because in the days of bush airplane flying, pilots used that as a landmark to find their way back to Fairbanks. Basically, line yourself up with Finger Rock, and which way the finger is pointing, that you follow that course, and that takes you back to Fairbanks. Seriously, that's what it did. Well, up there, you used to stop, and people look around and look at the scenery and swat bugs and what have you. And I used to always take a can of soda, and I just have it in the ground somewhere, and I just left it there like for the season. And I bring the people over and go, okay, I put a thermometer on the ground, and you read the temperature on the ground. It's like 60, 70, whatever it might be, depending on the time of the year. And then I reach down into the ground, and I pull out this can of soda, and I start handing it around. People go, holy crap, it's so goddamn cold! Because it's permafrost, it's a refrigerator, it's a freezer, it was keeping that. And the can of soda didn't freeze because of freezing point depression. It's all solutes in there. But, it was a demonstration of how cold the ground can be. Rosen Komani, who is assistant professor of Earth and Environmental Sciences at Columbia University, has also been studying the thawing permafrost and was the lead author on the first study to show that Alaskan tundra was now a net emitter of CO2. She was the pioneer on this. Christmas Day last year, the North Pole wasn't frozen. The sea ice isn't freezing. The soils aren't freezing. This is Dr. Kamadi saying this. This past year, 2017-2018, a lot of Alaska's North Slope and into Siberia never froze through. They had a very early snow, which provided an insulating layer, and those soils never froze, and the amount of CO2 and methane coming out was quite high. Now, I've done recent videos discussing how an early snow creates this insulating layer so the ground does not freeze. But when you think about, especially, up on the North Slope, you got Prudhoe Bay there. They rely on that ground being frozen to run the heavy machinery over it, be it the trucks, the loaders, dozers, whatever. That ground is soft, that's going to cause problems. As it is, the way they build those roads are, they just bring in piles and piles of rock called tailings to build it up. Well, that's going to start giving way, and we're already seeing that. We're already seeing parts of, where the ground is thawing, so now roads and buildings are all buckling. I did another video discussing the impact of a warming Arctic on communities that live, in the circumpolar regions. So if you haven't, please check out those videos. So, climate change is here. It's upon us. We're now seeing the feedback loops. And I personally am not optimistic. Even if we will stop this very moment, no more CO2 emission, not likely, but even if that were to happen, there's so much thermal inertia, there's so much other stuff going on, all these feedback loops, that it's just going to keep going and going and going. It may slow down, it may keep going and going. Now, little caveat to the jet stream aspect that I shared with you. Still don't quite know the role of the oscillatory systems, the PDO, the Pacific Decadal Oscillation, the North Atlantic Oscillation, the Atlantic Multi-Decadal Oscillation. So they may have a role to ameliorate, modify, we don't know. I am in the middle, I keep saying this, but I am in the middle of putting together major videos on ENSO, Pacific Decadal Oscillation, Interdecadal Pacific Oscillation. Some scientists consider them separate, others think they're coupled together. I think the latter. I think they're coupled together. So when I think IPO, I just think part of the PDO. I think the PDO is more of a driver of system. And then you have the NAO, the North Atlantic Oscillation. You have the Arctic Oscillation. And you have the Atlantic Multi-Decadal Oscillation. You got all these systems. And how they're going to affect things. So these videos are coming. I think I'm finished with ENSO and the PDO. So I want to get onto the... I thought I was going to make like 3 videos. I think I'm going to make like about 4 or 5 such videos. So I'm working on the NAO and the AO and then the AMO. So be on the lookout for those. These will probably be lengthy videos. But anyway, we are now seeing the old saying, chickens are coming home to roost. It's happening. It's going to affect humans and the ecosystem, organism. Thank you for watching. Thank you for your time. Hey folks, this is Jim here reminding you to please subscribe to my channel and please share my videos with others. Also remember to click the bell so that you know when I drop in a new video. I also ask that you please consider becoming a patron of my channel and support the work that I do by going to patreon.com/Science Talk with Jim Massa, each word separated by an underscore, and becoming a patron. It's asking for as little as $3 a month, cost of a cup of coffee, to support the work I do and keep my informative videos coming your way. Thank you for your support.